This is a typical site office where we have, first of all, we have drawings. And the drawings are supposed to be properly displayed on the walls. So over here, you can see the structural drawing of the basement floor. It is shown there. It's a structural drawing of the basement floor. And then over there is another drawing which shows the details of the bases. The bases with the column bases are shown, and typical sections are also shown. Different types of columns are shown. We have end columns, rectangular columns. We also have round columns as shown, and a section is taken and shown. It is properly displayed so that as the contractor does their work, they are able to interpret the design to the ground. So if you look, for example, on this one, this is a plan and the scale is 1 to 25. Scale 1 to 25 as shown there. And this is very important because it's a big enough scale to show all the details. When we talk about scale, where we were on the ground, I would talk about that being scale 1 to 1. Together, that scale 1 to 1 is the real life. But when then you come to the drawing, you cannot have a drawing that is as big as the real life. That's why you scale it down, and there are certain scales which give you proper, you're able to see clearly what is expected. When I look at the plan, the sections, I'll be able to tell this is a reinforcement bar, and what you see as a round shows the bars are going into the third dimension. So the drawing is a direct interpretation of what the engineer, the structural engineer designed, and is taking it to the ground. On this table are also files which show other details to smaller scales so that the contractor is able to quickly go around. So within the office of the contractor's office, there is also a table, a clean table. There is also lighting. There are also helmets, protective gear. There is also there should also be the engineer, the surveyor equipment. So for work to be properly done, we are showing an example of what is expected on a good, well-managed site. So keep watching, and we'll tell you as we go along to learn how a construction is done. This is foundations, construction of the foundations. So we are at the second basement. We want to take you to where we already have some reinforcement in place. So let's see how the reinforcement is normally placed. This is a column base with some reinforcement, as you can see, and the reinforcement is placed in two directions as shown. The vertical reinforcement bars you see are called starter bars, and this being a second basement, there is some retaining wall, and therefore the big column base is integrated with the footing for the retaining wall. So this is an example of how we place reinforcement. And before reinforcement is placed, there is what is called blinding. Let us see, this is an example of where now the base has been concreted. I'm standing on the which has been concreted. These are the column starter bars. And the column starter bars should be at a height can see from here, there. Let's look at another case. Some of the activities done on the foundation is bending bars. And this is how you bend a bar. This is how you bend a bar. You can see the fundi is bending a bar like that. So when you see what is called a bar bending technique, the fundi bend the bar like that. If I hold this bar, you'll be able to see this bending. It bends so that it will have proper anchorage, and it is bent like that on side. Let's move to some bases. These are the bases of the bases that has already been done, waiting to be placed. All right. Let's look. These bases have here. Let's look. So you can see this is another round column. And you see the columns, the bars are 1, 2, 3, 4, 5. For round columns, that's the minimum number of bars. And for a square column, you can see how it is placed. You can tell you it's a round column. What you see behind me is part of this is a pipe that pumps concrete from the ground level all the way to the end, so that you don't have to keep bringing the concrete along. So let's follow and see what is happening. You can see what's happening. Let's go nearer so that you hear me speaking. Let's go nearer. Let's go nearer and hear the end of the bar. If you look at this, this is part of the retaining wall, and where I'm standing is the footing. Behind me you can see a very unstable ground. When you hear of instability of slopes, this is what it means. When you cut unstable soil vertically, there is a danger of it collapsing. That's why you need to cut it at 45 degrees, especially if you have the space. So for now, let's keep watching. This is an example of a rectangular column. As you can see, the bars form a rectangle. We have 1, 2, 3, 4, 5, and 6. These are the links. These are the links. When you design and talk about links, these are the links. The links are the ones which hold the main bars together. So these are the main bars. So I had talked about going to the end. I don't want to be too near to an unstable slope because it can actually collapse. This is another example of a rectangular column. Again, find it has links. There are links. Come closer here, you will find an example of stability of slopes. So when you talk about geotechnical investigation, and when you study stability of slopes, this is an example of unstable slope. This is a very unstable slope. It will actually collapse at any time. Now, most of it has collapsed, so we don't want to stand very close to it, so that if it collapses, it does not collapse on us. We are going to pour concrete work. This is concrete from the batch where it's being batched up there. If you look up there, you'll find the batching of concrete is being done there. Some of it is being ferried on wheelbarrows. And this is an example of a slope that has collapsed because the unstable ground was cut at a vertical angle, 90 degrees. That is very unstable. So again, remember here we want to learn about reinforcement. We also want to look at geotechnical. So we are learning both at the same time. So keep following and we shall learn. Now we want to go to the concrete batching and investigate what goes on there. Keep watching. You can stabilize the slope using a system like what you see. All those marine boats you see around there are helping to stabilize the slope so that the ground does not collapse as we wait for the retaining walls to come up. We should come up as fast as possible to avoid undermining the boundary wall. What's going on here?
Thank you, engineer. This is the batching area. Right now we had a small problem with the mixer. That's why they are trying to repair it. But now this is where we do our batching, the concrete mixing, as per the ratio in the engineer's instructions. So here
Yes.
we are doing 25, class 25.
You are doing class 25.
Yeah.
How? Can you take us where you are doing that?
Okay.
Is it possible for us to go there?
We can pass through here.
Okay. Let us pass through there. We want to have an experience of what goes on a site. As much experience as possible on what goes on a site, especially during foundations. So just guide us. How do you ensure that your class is achieved?
We are doing class 25 here. That means we are doing 1:1.5:3.
1:1.5:3.
Yeah, that means we are doing one cement, 1.5 sand, and 3 ballast. And
let us see your sand. Where is your river sand?
we have the river sand here.
This is river sand.
Then we also have the.
This is river sand.
Yeah, that is the river sand. We
And
also
what
have
is
another
this?
Sand here called the rock sand.
This is rock
This is
sand.
rock sand. It is from a crusher. Then it is washed. So it is still. It is also a good sand.
What is the grade?
boats.
What is the grading of this?
The grading this.
It looks finer than the river sand.
Yeah, here we have 0.2 and 0.3 size of the sand. Yes.
Okay.
So, as I said, we take 1 bag of cement. Then we do one and a half sand, and that is the ballast. We do three of them. If you are measuring with a bucket, you make sure 1 bucket of cement, 1.5 bucket of sand, and 3 buckets of ballast. Then you put them together in that mixer, and after mixing, now that is when it is pumped.
Can you show us the bucket you use? So you don't batch by weight, you batch by volume.
We do by volume.
Let me see the bucket you use.
We measure different rate. This one is 1 bag of cement. Yeah. So if you are doing 1 bag of cement, you should put this 1.5 of sand, then 3 of them ballast. Yeah.
Thank you very much for watching.